Okay, this is our 8th lesson in Unit 4. Okay, what we're looking at today is the discriminant. Okay, so what we're looking for here is that if you're asked about the nature of the roots of an expression. Okay, so what we used yesterday, the quadratic formula, okay, this tells us the roots or the solutions to a quadratic equation. However, if all we're asked for is the nature of the roots, we're not actually looking for the exact point. We just want to know roughly what does the graph look like. Okay, now we have 3 possibilities here. Either our graph will look something like this. We'll have 2 roots, okay, and we would refer to those as real and distinct roots. Okay, so basically, if we did the full calculation, we would get 2 solutions. Okay, the other option would be that our parabola comes down like this. And you can see there, it doesn't actually cross the x-axis, okay? Has no roots. If we worked this through, there would be no answer. Your calculator would come up with an error, and we say there are no real roots, okay? And our third possibility would be that our graph comes down, and it just touches that x-axis once. Okay, so that turning point of the graph is right on the x-axis. There would only be one solution. If we worked through the full problem using the quadratic function, we would get the same answer twice. Okay, so what we say is that this has equal roots. Okay, we'd get the same answer both times doing the plus and the minus from this, so it's equal roots. Okay, or one root would be a simple way to put it, but technically speaking, we say equal roots. We prefer that. Okay, now the way we figure these out and the way that the question becomes much shorter and much more straightforward is that we focus in on this part of the equation here. This is what we call the discriminant. Okay, call it this because it discriminates, it differentiates, it treats differently these 3 different things. It's what tells us whether we have real and distinct roots, no real roots, or equal roots. Okay, it tells us how many solutions the problem has. Now, if we look at it, if this number in here, once we've calculated our b squared minus 4ac, if this is positive, then brilliant, we've got a plus and a minus, and that gives us our 2 answers like we looked at in our last lesson. So if b squared minus 4ac is positive or greater than 0, then we say there are real and distinct roots. If this number is a negative, okay, and feel free to pause the video and check this if you like, you should know this already, but feel free to check it. If this number here is a negative, we cannot do the square root. Pick any number you like, you cannot square root a negative number. So what that means is that if this value here, this b squared minus 4ac, is a negative number, then there are no answers. It cannot be calculated, and so that means the graph would look like this. There are no roots, no solutions to this equation. So we would say that if b squared minus 4ac is less than 0, then there are no real roots. Okay. Our third possibility, equal roots, comes when this expression here is exactly 0. Okay. If you think it through, we know by now that the plus and the minus splits off into 2 separate calculations, one with a plus, one with a minus. If that number there is 0, then obviously adding on 0 and taking away 0 gives you the exact same thing. Okay, so that's how we get the same answer twice. So here are your 3 possibilities, and if you're asked for the nature of the roots, then you don't have to do the full thing, you just need to do this little discriminant part. Okay, so what I'm going to do is I'm just going to show you a few examples. Okay, And for each of these, we're going to be asked to find the nature of the roots. Okay, so find the nature of the roots in each case. Not find the roots. Find the roots would mean doing the full calculation and getting our answers. Find the nature of the roots means we just need to do this wee discriminant bit. So the first one we're going to look at is y equals 2x squared plus 3x plus 4. Okay, now remember from our last lesson on the quadratic formula, a, b and c are 2, 3 and 4 in that order for this question. Okay. And what we're going to do here is just say, well, b squared minus 4ac is going to be 3 squared minus 4 times 2 times 4. 3 squared is 9, 4 times 2 is 8, times 4 is 32. 9 minus 32 is obviously going to be negative 23, okay? So b squared minus 4ac less than 0, therefore no real roots. Okay, simple as that. You just get this answer. All you're thinking about is it positive, negative, or 0. Okay, second one we're going to look at. We're going to do the same thing, but this time our equation is y equals 3x squared plus 6x plus 3. And again, we're going to say b squared minus 4ac. In this case, b is 6, so 6 squared minus 4 times a and c are both 3 in this case, so times 3 times 3. 6 squared is 36, 4 times 3 is 12, times 3 is also 36. That gives us 0, so in this case we're saying b squared minus 4ac is equal to 0, therefore equal roots. Okay, and the third one we'll look at, and chances are you've guessed where this one's headed already, but the third one we're going to look at is y equals 2x squared plus 3x minus 4. So same as the first one, this 4 is now a negative though. And again, we're going to say, well, b squared minus 4ac equals 3 squared minus 4 times 2 times negative 3. 4 times 2 is 8. Sorry, that should be a 4 in there. My apologies. 4 times 2 is 8, times 4 would be 32, but because we're multiplying by this negative, this becomes 9 plus 32, 41, and so in this case, b squared minus 4ac is positive, it's greater than 0, so we have real and distinct roots. They're real, they exist, and they're distinct. They occur at 2 different points. Okay, and that is all there is to it. Okay, the place most people go wrong with these questions is not reading it properly. If you're asked for the nature of the roots, it becomes a far more straightforward affair. Don't let yourself get confused and do way too much work trying to find roots that don't exist because they were actually looking for this answer.